Again, use process of elimination to get the. Oh, you can't see it. What am I thinking?
You can go mad and pull it up all hard. Nah.
I was showing you that the whole time you weren't seeing it. I changed the problem, that's why it says it has a red X. It was correct.
Oh, on sign? It went to sign?
Yeah, so I didn't work it, but that's why it has a red X. All right, choose a graph. Again, just use process of elimination. If you put in 0 for theta, cosine of 0 is 1. 3 times 1 is 3. 3 plus 6 is 9. So at 0, when it's heading out to the right, there needs to be a point at 9. So is this one a chance? No. This one? 9 is here, right? And it's not there, so no. This one? Yes, it has a chance. D? No. Only one that had a chance was C, so it has to be C. You guys all right with that? All right, area. Let me, stays over there. Let me write this function on the board. R equals 6 plus 3 cosine theta.
Yep.
Okay. So I want to try to keep it somewhere where it doesn't cover up the function, but it's on the board over there on the left. So let's figure out what values of theta generate this top half, because we can see the bottom half is the same, correct? Does everybody agree? So cosine of 0 is 1. And that gave us 9, so that gave us this point over here. What happens if we do pi over 2? Cosine of pi over 2 is 0. 0 times 3 is 0, plus 6 is 6.
6.
1, 2,
It's at
3,
6.
4, 5, 6. That gives us this point up here, doesn't it? 0 to pi over 2. Okay. My last example for the whole semester. After this, all I'm going to be doing is answering questions. So, we're going to find the area of one petal for one of these. All right, one petal. We have R equals cosine 5 theta. If you remember, when that coefficient of theta is odd, that is how many petals there are. So this one has 5 petals. It could be A, there's 5 petals there. Could not be B, could not be C. It could be D. There's 5 petals there. It's either A or D. Do you agree?
Yeah.
All right. Let's put in 0 for theta. That's when it's pointing out like that. What's R if theta is 0? 1. Can it be A? No. Has to be D, doesn't it? All right, area. Cosine of 0 is 1. Cosine of what? So this thing comes back to the origin where R is 0. Cosine of what is 0? Cosine of pi is -1. Somebody said it.
Part two.
Pi over 2. Cosine of pi over 2 is 0, right? So we need to find the theta for our function that brings this, that gives us pi over 2 inside the function. See, we have 5 theta in there. Let me write it up here. Let's make sure we understand what we're doing. Cosine of 0 gives us this point out here. Cosine of pi over 2 will take us to there. It'll give us the top half of that pedal. But we can't just use pi over 2 because we don't just have theta in there. We got to know what value of theta that makes this pi over 2. So scratch paper will work. Solve that. Multiply by 1/5 on each side. Yes. And we get theta equals pi over 10. Do you see that when we put pi over 10 in for theta, this will be pi over 2 inside of cosine? Do you guys see that? So if we go from 0 to pi over 10, that'll calculate to pi over 2 inside the function. So 0 to pi over 10 will give us the top half, won't it? To get the bottom half, that's symmetric, we just multiply by 2. So here's our integral, our area integral. We're going to do 2 times 0 to pi over 10 of cosine 5 theta d theta. Oh, wrong. Messed up my last example. Very frustrating. 1/2 cosine squared 5 theta d theta. This. So again, that would give us the top half of the pedal. Multiplying by 2 gives us the entire pedal. Good? All right, here we go. Bring out the half, that cancels with the 2. We're going to need to do a u substitution. We will let u equal 5 theta. du will be 5 d theta. So that means we need to get that 5 d theta, we need to multiply by a 5 in here, which we'll have to counter it with a 1/5 on the outside. Now we have 1/5 cosine squared u du. We can adjust the bounds. If we put pi over 10 into theta here, 5 times pi over 10 will be pi over 2. And if we put 0 into theta here, 5 times 0 will be 0. Now we use that formula for cosine squared, which is on the sheet. So this equals 1/5 times u over 2 plus sine 2u over 4, 0 to pi over 2. Let's go ahead and evaluate it in terms of u. We could rewrite it and put it back in terms of theta. We would substitute 5 theta in for u to do that, and then take the original bound. Let's go ahead and use this one. So putting in pi over 2, if I put pi over 2 in for u, this will work out to what? Pi over 4. And plus, if I put pi over 2 in for u, the 2's cancel and we get sine of pi. If we put in 0, We're gonna get 0 here, we're gonna get sine of 0, which is 0. It's all gonna be 0. So we have 1/5 times pi over 4. Sine of pi is 0. 1/5 times pi over 4 is pi over 20. That is the area of one petal, assuming there are not any mistakes in there.
One petal?
What's that?
It's one petal?
One petal. See the shaded part?
Oh, sorry, I thought half a petal. Okay, sorry.
Oh, it was half a petal, but we multiplied by 2,
Okay.
which makes it one petal.
A whole
So there we go.
petal. I'm getting so confused, sorry.
What we can do, huh? Isn't it? You see that, well, you probably, in rectangular coordinates, X and Y, would have been a lot harder, wouldn't it? Yeah, we'd have to come up with some kind of function that generates that curve. We'd have to convert that to a rectangular function, which you guys learned in some of those. Any questions? For some problems, yes. Yeah, for some problems, yes. Our book, I don't think focuses on it.